In this lesson, we're going to take a look at a real common problem, which says that if we start off with two charges, and we'll put a big old negative charge over here. And let's call that -4 microcoulombs. And then we'll put a positive charge over here. And we'll call this +7 microcoulombs. And then we need the distance between them. And let's call that distance 20 centimeters. So the prompt for this would be, where could a third charge be placed so that it feels balanced forces, or the net force would equal 0. So feel balanced forces means that the sum of the forces acting on it would be equal to 0. Okay, so let's do a thought experiment here. Let's establish an axis that goes through the center of each. And then let's just think about a couple of locations. So I'll just grab a little prop here. We'll use this nut. Okay, so let's suppose if I put my charge right here, and I don't even know what it is. So let's assume it's a positive charge. So if it's a positive charge, it's going to feel a force this way from the 7, and then it's going to be attracted to that one. So there's no way that those two forces could cancel each other out because they're not in the same line. So the only place where, and the same thing goes for over here, or here, or here, anywhere else not on the axis. So it's only possible for it to exist on the axis. So let's break this up into 3 different zones. Let's call this zone 1, which would be outside +7, and zone 2, which is in between, and zone 3, which is outside the -4. So in this location, again, assuming a positive test charge, it's going to be repelled by the +7 and attracted to the -4. So that's a potential place, because they're in opposite directions, the forces are, but it's always going to be closer to the bigger force. So that's no good. So that's out. How about in here? We place it in here somewhere. Well, again, if it's a positive charge, it's going to be repelled by the +7 and attracted by the -4. So positive charge repelled by this and attracted by this. So being repelled by the +7 is a force to the right, and being attracted by the -4 is also a force to the right. So they're not going to cancel. So region 2 is out. And then out here, attracted to the -4, so that's a force to the left. Repelled by the +7, that's a force to the right, so that could work. And we're closer to the -4, so that means that has a chance of working. So that's what we're going to go with. This is our winner right here. Okay, so we're now going to set those forces equal. So set forces equal. Great. Well, let's assume that the distance from the -4 is some number x. It's going to be a different distance out here, so that's going to be x plus 20. And I don't know what what this charge is going to be. So mystery charge, Q. Q represents any charge. All right, and we're going to set them equal to each other. So that's going to be K, the Coulomb constant, times 7 microcoulombs times little q. I don't know what it is yet, but we'll find out. And then the distance from here out to where we think we're going to find this is going to be x plus 20. And that quantity is squared. And we set that equal to K times 4 microcoulombs times Q divided by x squared. Now it looks like I'm breaking lots of rules here. So number one, they're not in SI units. Number two, what's Q? Should I put a number in there? So, and what about the minus sign? I didn't put a minus sign in there either. And we've already actually gone through that. So like I said before, we don't want to rely on algebra to tell us the direction of things. We want to set ourselves up to know that it's going to work out based on the logic of this argument. So now there's lots of cancellation. It's a real cancellation fiesta. And so the microcoulombs are gone, Q's gone. So it doesn't depend on whether it's positive, negative, big or small. It's going to work for any charge. And so that's about as much. Oh, K is canceled, of course. And then we do some cross multiplication. So that means that 7x squared is going to be equal to x plus 20 squared. Okay, it looks like we bought a ticket to quadratic formula town here. So 7x squared equals x squared plus 40x plus 400. And now to get it in a form where we can apply the quadratic formula, that's going to be 6x squared minus 40x minus 400 is equal to 0. So x is equal to, we'll get 2 roots out of this. So I'm going to share my screen. We're going to go out and take a look at the quad solver. Good. So share screen. That looks good. Okay, we'll go out to our website. We're going to type in quad solver. There we go. That one looks fine. And so we'll go ahead and type in the numbers. So 6 and negative 40 and negative 400. Good. So I have 2 roots, and we'll talk about what those roots are. What they mean. So I'll round them off to 2 significant digits. So negative 5.5 and 12.2. Okay. Yeah, so only the positive number makes sense. So that means that 12.2 is going to be out here somewhere, something like that. Okay. Now, let's do a switch. What if they were both the same sign? What if they were both negative? So what if it was negative 7 microcoulombs and negative 4 microcoulombs, and then the distance between their centers was going to be equal to 20 centimeters. So everything else the same, except now they're both the same sign. Okay, we'll bring our nut back, and then positive charge is going to be attracted to both of them, so that won't work. And then over here, it's going to be attracted to both of them. That won't work. So it's only in the middle. So region 1 does not work. Region 3 does not work. But region 2 is the winner. And the setup is going to look very much the same, except that again, we're not going to worry about the minus signs because we're just going to let we already applied that logic. All right, but what are the denominators now? Well, if x is again measured from the 4, and we put x squared down here, then what's going to look different is that this is now going to be 20 minus x squared. Okay, again, we have lots of cancellations, so the q's are gone, my coulombs are gone, k's are gone, and I set up for the quadratic formula, so that's going to be 7x squared is equal to, whoa, I forgot the 4 on the last one. Yikes. Whoops. Okay, we'll just run the quadratic formula again really quick. Okay, that's more like it. Okay, we'll stop sharing and then come back to finish the algebra for this one. Oof, yikes. Okay, so won't forget to do the distributive property this time. Okay, so 400 and we can see that a lot of the terms look similar. And so all right, so now if we take a look at the quadratic expressions, that the only thing that's different is the sign of this middle term, the linear term. Okay, so let's go back to our quad solver again. And we only have to change one thing. So we're just going to delete that. And now we see what happened is that the terms switched on us. Okay, that's comforting because that tells me that I did the math right. Okay, what are the takeaways? So I did my little botched algebra down here, so sorry about that. But the question is, so 61.9 is way the heck out here somewhere. And part of that is because they're pretty far apart. But then what does the negative number mean? And the negative number actually means that if they were both the same sign, then now these two roots have switched signs. So now it's the 8.6. That's the correct answer. And this one was the 61.9. All right, so the math does always have something to say about it, but it might not just have a big application in real life. All right, so sorry for that boo-boo, but I think we fixed it in the end.